Hi, let's start part 3 of this module. Here in Module 7, we've been working on rational number concepts and procedures. And now we're going to look at some examples, both with video and on paper, about how you could incorporate some of these concepts within intensive intervention. So in this part, you're going to learn how those concepts and procedures that we talked about in parts 1 and 2 of this module could be utilized within intensive intervention. So where are we? A question I ask myself often. We are with these blue arrows in our DBI diagram. So we're focusing on those orange areas. That's our instructional platform and the adaptation that we might make to the instructional platform. And within that instructional platform, we're focusing on using evidence-based practices to deliver the instruction. It doesn't matter whether we have an evidence-based intervention or whether we're using evidence-based strategies, we need to be thinking about the following, and that is using explicit instruction, multiple representations, and concise language, as well as helping students build fluency, focusing on problem solving and including a motivation component. Now, I always like to think about these as these are important during instructional delivery. These are strategies that should be embedded within that instructional platform. And now we want to take these and combine them with all that stuff about rational numbers that we just learned. So let's go ahead and watch some intensive intervention. So as I just said, let's watch some intensive intervention. And I'm super sorry, but the tutor that you have to watch here is me. And what I want you to be watching out for in this video while I work with this student, Eric, is the important components of delivery of instruction. So how am I using explicit instruction? Do you see modeling? Do you see guided practice? I think you're going to see both of those. How do we use multiple representations? I can already see some fraction circles out here on the table, so you might want to keep your eyes open for use of those or use of other representations. And then finally, what's the language that I use with this student? Is that language concise and is it mathematically correct? I want you to be thinking about those things as we look at this video. Go ahead and watch. I'm going to work on a fraction today, and let's see. I'm going to work on a fraction, this one right here. This fraction is 2/3. What fraction is that?
2/3.
2/3. Have you thought about 2/3 before?
Yeah, I've seen it come up a ton.
It does kind of come up a ton, right? You've probably seen it in school and all kinds of things like that. So I'm going to show the fraction 2/3. So the first thing I'm going to do is I'm going to use these fraction tiles, right? So, and here is my whole. What is that right there?
It's a whole. It's a whole.
It's a whole.
Whole one.
It's a whole one, right? All right. And so I want to focus first on this 3. This 3 represents the denominator. What does it represent?
It represents the denominator. In other words, it's sections of this.
Yes, exactly. So we have to take that whole and we have to like break it into parts, right? And are those parts going to be equal size parts or?
Oh, equal size.
Yeah, they always have to be equal size parts. So I should have had this already out here, but I'm going to find my third pieces. And I want you to take this whole and I want you to break it or show me how we could break that into equal parts. What would that look like? Okay, let's get our other third out here. Awesome, and there's my other third. All right, so we've taken the whole and we broke it into how many parts?
3.
3. Now let's focus on the numerator. What is this right here?
2.
The 2, the numerator. So can you show me 2 of those 3 parts? What would that look like? 2. And you know what? I'm going to go ahead and let's go ahead and take that away. So what fraction did we just show there?
This is 2/3.
2/3. Now I have some questions about 2/3. So thinking about this model here, I want us to think about, this is if we assume that this is kind of 0 over here, and this is 1, all right, is 2/3 greater than 1?
No.
No.
It's always because every time you go down to the higher numbers, it's always getting smaller.
Okay, so tell me a little bit more about that, what you mean by higher numbers. Are you looking at the numerator or the denominator?
I guess I'm more talking about the denominator.
Yeah.
And that because since we're breaking it off into more pieces, it keeps getting smaller and smaller and smaller.
Smaller and smaller. And if the numerator is a number that is less than the denominator, is this going to...
It gets bigger and bigger.
So what do you mean by bigger and bigger?
It could potentially get bigger since there's more parts to work with.
Yeah, so if I have a numerator of 1, then is 2/3 going to be bigger or smaller than 1/3?
It's going to be... Okay, say that again.
So if I have a numerator of 1, so let's say I had 1/3, so is 2/3 going to be greater or less than 1/3?
It's going to be greater.
Greater. What would be another fraction with a denominator of 3 that's going to be greater than 2/3?
3/3.
3/3? Can you think of another one?
2.5.
2.5? Oh, that's definitely going to be greater than 2/3. Now with this 2/3, since you told me it's less than 1, can you tell me, is that 2/3, is it going to be greater or less than 1/2? What's a way we could figure it out? Do you want to use the fraction tiles?
Well, this is 1/2.
Okay. So if I was thinking that this is 0 here and this is 1, and I wanted to think, I'm going to pick up your 1/2 piece. I wanted to ask myself if 2/3 is greater than 1/2. So is 2/3 greater than 1/2 or less than 1/2?
2/3 is greater than 1/2.
Yeah, how do you know that 2/3 is greater than 1/2?
Because since it's adding up two of the equal pieces to one of the bigger pieces, and since this only covers half, and this one covers a 0.5.
Yeah, so it kind of covers like more than a half, right?
Right.
So what I like to think about is when I have this 2/3, I'll go ahead and put it back here. When I have my 2/3, let's say that, have you worked with number lines before with your classroom teacher?
Yes, ma'am.
Yeah, so if I think I've got my number line, I'll go ahead and I could just draw this along here, all right? Just remember, number lines always keep going. Here my number line is 0, here it means 1. So where does 2/3 fall in the number line? Falls about right there, right? Do you want to label that? And then where does 1/2 fall on my number line? You can go ahead and label that one too. Nice, I like your labeling there. So is 2/3 greater than 1/2 or less than 1/2?
2/3 is greater.
And how could you, like, if I wanted you to tell me why it's greater than 1/2 on the number line, what could you tell me?
It extends out farther to the 1
than
the half.
It extends out further. And so would you say that 2/3 has like a greater value than 1/2? Let me ask that question kind of in a different way. If you have 0 and if you have 1, which has a greater value, 0 or 1?
The 1.
Okay. If you have 0 and 1/2, which has a greater value, 0 or 1/2?
That 1/2.
1/2. Now let's think about, if you have 1/2 and 2/3, which has a greater value?
2/3.
2/3. If I asked you, would you like 2/3 of a pizza or 1/2 of a pizza? Which would you like to have?
I would like to have the 2/3 of the pizza since I'm getting more pizzas.
Yeah, you probably always want more pizza. I always want more pizza too. All right, that was awesome. So I've liked you showing 2/3 this way. Now I've got these fraction circles here. I bet your teacher has worked with you in the classroom. I want us to show the same fraction. We're going to focus on 2/3. So let me get my 2/3 pieces out. Do you see them here? Oh, there they are. You saw them before I saw them. Can you show me the fraction 2/3 with those? Okay, so oh, that's awesome. So put that back in there because I want to ask you a question about that. What did you show me right there?
It's a whole third.
It's a whole, and it's broken into how many equal parts?
It's broken into 3 equal parts.
Fantastic. And then how did you show me 2/3?
By doing this.
I liked that.
And making it look like Pac-Man.
Yeah, kind of making it look like Pac-Man. So what fraction do you have there?
It's 2/3.
2/3. All right, so we'll leave that there. You can just keep your 1/3 piece to the side. I want to show you another way to show the fraction. So we've got 2/3 this way. Actually, move our 1/2 there. We've got 2/3 this way, and then I can also show 2/3 this way. So imagine I have 3 counters. All right, that represents my denominator. What does it represent?
The denominator.
Denominator. And our denominator has what number in it?
It has 3.
3. So we wanted to have 3 parts. But what if I do this? What did I just show you there?
You have 2 red. You have 2 red spots and 1 yellow, so it still means 2/3.
It still means 2/3. So what fraction did we show here with this, as I call my length model? What fraction did we show?
We showed 2/3.
So this is what I call my area model, because it's an area broken into equal parts. What fraction did we show?
2/3.
2/3. And then here we have our set model. What fraction did you show that way?
2/3.
2/3. So what's really cool is that we can show 2/3 in many different ways. Now, before I write these concepts, you can see that I was using a lot of explicit instruction, doing a lot of modeling with Eric, asking him lots of questions. I would say that he was very involved in the lesson. Hopefully you would see the same thing too. I was very focused on using the correct math language. And sometimes I use the informal language that Eric used, but then I also use the formal math language, and I'll just talk about that right now. So in terms of the concepts, I'll write all these things up here. We were focused on, in this lesson, on the fraction 2/3. It's always a good fraction to use with students. It is a proper fraction, but it's not one that they may have seen all the time. A lot of times they work with like 1/4 or 1/2 or 3/4. So I chose a fraction that Eric was familiar with, but it may have not been something that he had done a lot of modeling with. And the idea here was to expose Eric to different ways to model fractions. So in terms of the concepts here, we first introduced the idea of the whole. Here we got out the fraction bar, and Eric talked about that mean one. Another concept that we really focused on is that denominator, and the denominator is broken into equal parts. Now, what was interesting here is that his definition involves the term sections. I'll go ahead and write that over here. It's like, oh, it's broken into equal sections. That's an informal way to talk about fractions. And so then what I tried to do is redirect him and talk about equal parts, and he did an awesome job with that. And then totally was like, yeah, the fraction's broken into equal parts. Notice I didn't just say parts, but I said equal parts. So another important concept related to the denominator. Then we focused on the numerator and what that numerator tells us about the fraction. So we did some practice there and some demonstration of the numerator. I love the part where Eric uses the fraction circles to show 2/3 and immediately zooms off one of the parts to show the numerator of 2 of those 3 parts. And then the other concepts that we worked on here were the models of fractions. So I'll go ahead and kind of write the models right here. And you can see that we used the length model. That's where we were using the fraction tiles, so seeing fractions as displayed on a number line. We used the area model. That's where we use the fraction circles, so seeing an area divided into equal parts. And we use the set model. That's where we use the 2 color counters to show a set of 2/3. So this was very, very conceptual, helping him understand the whole, the denominator and the numerator, and using different models of fractions to help him see fractions in different ways. Now, another thing that we got into, and I guess I'll write it over here, was understanding, and I was trying to get into proper fractions and improper fractions, but we talked about whether it's greater than 1 or whether it's less than 1. And in the same way, Eric first talked about things that are bigger or smaller. That's the informal math vocabulary. So I would keep coming back to like, oh, is this greater than 1? Is this less than 1? Sometimes I used his informal math vocabulary, and other times I tried to redirect to the more formal way, because we would always ask if things are greater and less instead of bigger or smaller. Now, in terms of the procedures, we did a little bit of writing in this lesson, but it was a really heavily focused on concepts. So that you can see that my concept section is really filled in here. And on the next video that we're going to watch, we are going to kind of flip things a little bit, and we're going to have a section that's going to be pretty heavily filled in on the procedures. But you'll always note that when we are teaching procedures, the concepts are always coming into play. So give me a minute to erase all of this work, and then we'll watch our next video. Yay! You don't have to watch me do teaching anymore. Now we're going to look at one of our intensive intervention tutors, Stephen, and he's working with Natalia. And we're going to see clips of 3 separate videos that are all one lesson related to fraction computation. And here Stephen is teaching addition of fractions with unlike denominators, which is one of the more complicated computational skills that students have to learn when it comes to rational numbers. So in this first part, we're going to, when thinking about explicit instruction, this is heavily on the modeling side. So Stephen is modeling how to solve an addition problem with unlike denominators. We're going to use representations a little bit in this. Actually, we're going to use them a lot. I'm sorry, I kind of forgot exactly what we're doing here. We're going to use multiple representations. We're going to draw the different multiples. He's also going to get out the 2 color counters to show fractions. And then I want you to see how Stephen is precise with his language. So how does he describe denominators and numerators? How does he describe multiples? Those are all important things to pay attention there. So let's watch this first part, and then I'll come back and introduce the next 2 videos.
All right, Natalia, today we're going to work on adding fractions, okay?
Okay.
All right, so can you give me an example of 2 fractions that have the same denominator?
2/5 and 4/5.
2/5 and 4/5, good. So when we add fractions with the same denominator, it's pretty easy, right?
Mm.
I mean, you just add the numerator, kind of like these right here. So in this first problem, we have 3/7 and 2/7. So if we wanted to add these, we would just add which number, the denominator or the numerator?
Numerator.
Numerator, good. So what is 3 plus 2?
5.
5. So we would write 5. And then what do we do with the 7s right there?
We keep them the same.
Keep them the same. So our denominator in the answer would be
5 7.
7 would be the denominator, and our answer would be 5/7. Good job. So when we have fractions that have different denominators, it's a little trickier, okay? So we have a sheet here that gives us steps to adding fractions with different denominators, all right? So the first thing we do, we want to model the fractions. So we are going to use these counters to model the fractions. The second thing we do is we find multiples of the denominators. The third thing, determine the lowest common denominator. Fourth, we determine how many new sets of each fraction you need and make them. And the last thing is we combine the fraction sets. All right? You think we can do it?
Yes.
All right. So let's look at problem B here. What does the problem say? What is that first fraction?
1/4
Plus.
2/3.
Good. So let's model these fractions first. All right? So the denominator tells us what? What does the denominator tell us?
The whole part.
So how many parts there are in the whole set, right? So how many parts are there in this whole set for this fraction?
4.
4, good. So we're going to count out 4 counters. 1, 2, 3, 4. And the numerator, what does the numerator tell us?
How many parts out of the whole?
Good. How many parts out of the whole are represented? So how many parts out of 4 are we going to represent there?
1.
1, good. So we're going to turn that one to its red side. So we have 1/4. All right. So we have that one represented. Let's do the next fraction. What is that fraction?
2/3.
Good. And how many pieces are there in the whole set?
3.
3. Good. So we're going to get 3. 1, 2, 3. And how many pieces are represented in that whole piece?
2.
2. Good. So we're going to turn 2 of them over to the red side. So now we have 2/3, right? Good. All right. So what's the next thing we do?
Find multiples of the denominators.
Find multiples of the denominators. Good. So let's start with the first fraction. What's the denominator in that fraction?
4.
4. Good. So we're going to draw a 4 in our chart here. And when we're finding multiples, you can think of it as kind of multiplying. You know, multiplying, kind of sounds the same. So that's what we're going to do. So we're going to find the first 5 multiples of 4, okay? So what is 4 times 1?
4.
Good. What is 4 times 2?
8.
8. What's 4 times 3?
12.
12. Good. What is 4 times 4?
16.
Good. And what is 4 times 5?
20.
Good. And now let's work with the other denominator. What's our denominator for 2/3?
3.
3. Good. So we're going to do the same thing. Find the multiples for 3. So what is 3 times 1?
3.
3, good. 3 times 2?
6.
3 times 3?
9.
Good. 3 times 4?
12.
12, good. And 3 times 5?
15.
Awesome, good job. Alright, so what's the next thing after we have found the multiples?
Determine the lowest common denominator.
Good, so how do you think we do that?
We look at the chart and we try to see which ones have the same number.
Good, so we look for the first number that is the same for both rows, right?
Mm-hmm.
Alright, so what number do both of these rows have in common?
12.
12, good job. So let's circle those 12s. Alright, and now, after we found the lowest common denominator, what's the fourth step?
We determine how many new sets of each fraction you need to make them.
Good, so to do that, we're going to see how many times we had to multiply to get the lowest common denominator, okay?
Mm-hmm.
So with 4, we had to multiply 1, 2, 3 times to get the 12, alright? How many times do we have to multiply with 3?
1, 2, 3, 4.
4 times, good. So how many sets of 1/4 are we going to have?
12. 3.
3, good. We're going to have 3 sets of 1/4. So let's make those 3 sets. We already have 1, so how many new sets do we need?
3.
So we already have 1. How many more do we need?
2.
2 more, good. So can you help me with this? So how many am I going to put out here?
2 more sets.
2 more sets, good. 2, 3, 4. There's another, and we need 1 more set. Good. So we have 3 sets. Alright, and how many times do we have to multiply the 3 to get the 12?
4.
4 times. So how many total sets are we going to need?
4.
4 sets. We already have 1. How many more sets do we need?
3.
Good. Can you make 3 more sets of that? Awesome, good job. Alright, so now the numbers that we circled on our chart represent the new denominator, okay?
Mm-hmm.
So that's going to be how many pieces we have in each set, alright?
Okay.
So we need to make sure that we have 12 in each of our sets. 12 total pieces, okay?
Mm-hmm.
So let's count the counters and see, make sure we have 12, alright? So count with me.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, we have 12 there. Let's make sure we have 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good job. So what is the last thing that we do after we made all those new sets? We combine the fraction sets.
Good, so we're going to combine the fraction sets into rows of 12, alright? So we're going to start with the red ones and see how far we get. So count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And do we need, is that enough? Do we need one more? We need one more?
No.
We have 11, but we need 12, right? So we need to put one more, right?
Mm-hmm.
It's going to be a yellow one because it's just going to be kind of a placeholder, okay?
Mm-hmm.
Alright, so we're going to put the other yellow ones down there too, but they're going to just be placeholders too.
Okay.
Alright. So when we combine the sets, our answer is going to be how many red ones we have in our new sets, okay?
Mm-hmm.
Alright, so how many do we have up here? How many red?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And how many total are there?
12.
12, so 11 out of 12. Good, so 1/4 plus 2/3 equals
11 12.
11 twelfths. Awesome, good job.
All right, so we just saw some modeling about how to add fractions with unlike denominators. On this next part of the video, you're going to see Stephen work with Natalia to do some guided practice. Now, she's going to do quite a bit of the writing, but you're going to see that he's there with her for every step of the entire process. So let's go ahead and watch what that looks like. Remember, I always want you to be cueing into how is the explicit instruction used, how are the multiple representations used, and what is the concise language that Stephen is using with Natalia.
So let's look at our next problem, Natalia. So what does this problem say?
2/3 plus 1/5
Equals good. So we have to figure out what 2/3 plus 1/5 is. All right. So what is the first thing we're going to do?
We're going to model the fractions.
All right. How do we do that?
We get the counters and we take 2 red ones and 1 yellow one.
All right. So 2 red and 1 yellow. And what fraction does this represent?
2/3.
2/3. All right, so there are 3 total pieces, right?
Yes.
And 2 are represented?
Mm-hmm.
Good. All right, how do we represent the next fraction?
We take 5 counters and have 1 red one.
1 red one. All right, 1, 2, 3, 4, 5, and turn 1 over to red?
Mm-hmm.
Good. All right, so we have both fractions modeled. And what's the next thing that we do?
We find the multiples of the denominator.
All right, how do we do that?
We take
So what's the denominator of the first fraction?
3.
3. All right, so let's write it on your chart. 3. All right. So how do we find the multiples of 3? Are we going to add or multiply?
Multiply.
Multiply, awesome. So what is 3 times 1?
3.
3, can you write it? 3 times 2?
6.
Good. 3 times 3?
9.
3 times 4?
12.
And 3 times 5?
2.
Awesome, good job. And what is the other denominator we have to find the multiples of?
5.
5, good. Awesome, so what is 5 times 1?
5.
Good.
10.
Good. Awesome, good job. Alright, so now that we found the multiples, what do we do?
We find the one that's common in both.
Good, so we find the least common, lowest common denominator. Alright, so which number in both of those sets do they have in common?
15.
15, good. So let's circle the 15s. Alright, so now we need to figure out how many sets of each fraction, right?
Mm-hmm.
Alright, so let's see. How many times do we have to multiply 3? 1,
1, 2, 3, 4, 5.
good. So we have 5 sets of the 2/3, and let's figure out how many sets of the 1/5 we have. So let's see. 1, 2, 3. Good. How many sets of the 1/5?
5. I mean, 3.
3. Good. Alright, so let's make our sets of 2/3 first. So how many sets of the 2/3 are we going to make?
We are going to make 5.
5 sets. Good. So we already have 1 set. How many more sets do we need?
4.
4. Alright. So can you make those sets for me?
Mm-hmm.
Awesome. Good job. Alright, so now we have our 5 sets of 2/3, and what do we do next?
Now we find our 3 sets of 1/5.
Good. So we already have 1 set of 1/5. How many more sets do we need?
2 more.
Good. Awesome. So we created our new sets, and what is the last thing we need to do?
We determine, combine the fractions.
We combine the fraction sets. Good. So the number that we circled is going to be our new denominator, and so we're going to make rows of 15. Okay? So we're going to use the red ones first, right? Okay. So let's count. 1, 2, 3,
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we're going to use the yellow ones as placeholders, 14 and 15. All right, so let's see. All right, so to get our answer, let's see how many red ones we have representing. All right, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 pieces out of how many?
15.
15. So what is our answer?
13, 15.
Good. Can you read it? Good. Can you read that whole number sentence for me, please?
2/3 plus 1/5 equals 13/15.
Awesome. Good job.
All right, so what you saw there was some really nice guided practice where Stephen was guiding Natalia through solving this problem. Now this last example that we're going to watch is going to be Natalia's independent practice. But do notice how Stephen isn't checked out. He's still there working with her every step of the way. Let's go ahead and watch that now.
So let's do one where you're doing it by yourself, okay?
Okay.
All right, let's look at problem D. What does the problem D say?
1/2 plus 1/3 equals.
All right, so what is the first thing you need to do in trying to figure out this problem?
Model the fraction.
All right, how do you do that?
We take the counters and we, for the first one, where 1/2, we use a red one to represent 1 out of the half. The 1 out of, yeah, the half.
All right, let me see it. Good. All right, so how do you represent the next one?
We take 1 red counter out of 3 to represent the 1 out of 3.
All right. Awesome, good job. All right, so you've modeled the fractions. What next?
We find the multiples of the denominators.
All right, good. Which denominator are you going to find the multiples of first?
1/2.
1/2, all right. Let's see. What is the denominator of 1/2?
2.
Good.
So 1 times 2 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and 2 times 5 is 10.
Good. Awesome. All right, and the other denominator is?
3.
Good.
3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15.
Awesome, good job. So you found the multiples, and what do you do after that?
We determine the lowest common denominator.
Good job. So what number in both of those sets are the same?
6.
Awesome, good job. So circle the sixes. All right, so what do you do after that?
We determine how many new sets we need to find the fraction.
All right, so how do you do that?
Well, we go to the, we jump to the numbers and see how many it takes to make how many sets.
All right, so how many times did you multiply 2 to get 6?
1, 2, 3 times.
Good. So you need how many sets of 1/2?
3.
Good. So let's see how many sets you will need of 1/3 too. So how many times did you multiply 3?
1, 2, 2.
Good. So how many sets of 1/3?
2.
Good. So let's start with the 1/2. How many sets do you need?
3.
3. So let's see if you can make 3 sets of 1/2. Good. And how many sets of 1/3?
2.
2. Awesome. So we have one. Let's see if you can make 2 sets. Awesome. Good job. And what is the last thing you do?
Combine the fraction sets.
All right. So how do you do that?
We take all of the red ones and put them together.
So the counters are going to be in sets of what?
They're going to be in sets of
What number did you circle?
6.
So they're going to be sets of 6, right?
Mm.
All right. So start with the red ones.
1, 2, 3, 4, 5, and we take a yellow one as a placeholder.
Good. And what do you do with the other yellow ones?
We take the yellow and just put them as placeholders as well.
Good. Alright, so what is your answer?
So we have 1, 2, 3, 4, 5 red counters. Out of 6, so it'll be 5, 6.
Awesome, good job. Alright, can you write your answer? Alright, so what does that whole number sentence say?
1/2 plus 1/3 equals 5, 6.
Awesome, good job.
All right, that was an awesome video where Stephen was teaching Natalia. And there, as I talked about as we went, but we saw the 3 parts of explicit instruction. We saw the modeling from Stephen. It was really focused on, he was showing Natalia how to add fractions with unlike denominators. Then we saw the guided practice where Natalia was doing a lot of the work, but Stephen was there asking her a lot of questions and helping her out, guiding her. And then this last thing we just saw was the independent practice where pretty much Natalia was able to solve this problem on her own. Now, just as we debriefed from the video around fraction concepts, I want to do a debrief about this video, and this one was really focused on procedures. But there were a few conceptual things that Stephen did talk about. And that was my comment before, that really anytime you are teaching mathematical procedures, those concepts always come into play. It's not always that necessarily true that if you're focusing on concepts, you're also going to be teaching procedures. Many times if you're teaching concepts, it's very conceptual and very focused on that. But if we are teaching procedures, we might be focusing on concepts. And what were some of the concepts that that Stephen emphasized? Well, first he was really emphasizing the idea about fractions. And so he talked about the concepts of a denominator and a numerator with Natalia. So those were important things to make sure that she understood those before he was ready to proceed with talking about adding those fractions with unlike denominators. The other thing that Stephen really focused on was understanding the models of fractions. And so he did a model where he used the set model, and he, I'll go ahead and color one of those in to kind of show a 1/4, but made sure that she had an understanding of the different models of fractions before getting to these procedures. Now, speaking of the procedures, Stephen, the nice thing that he did here is the first thing that he did was he introduced the steps. And so he had the steps written out on a little poster, and he read through those and introduced those to Natalia even before they got started. So it really gave her an idea of what they were going to do within the lesson. The second procedure that he really focused on here was the modeling of the fractions. So that's where this set model came into play. And then after modeling the fractions, he and Natalia worked on listing the multiples. So, and that goes all back to some of the stuff we've talked in previous modules about in terms of fluency with your multiplication facts. She had a really strong fluency with her multiplication facts, so it was super easy for her to list out the multiples. That's a procedure that she needed to have familiarity with before doing all the multiple work. The fourth thing that Stephen and Natalia focused on that was a procedure was changing the fractions to like denominators. I'll just put changing to like. I can't help myself. I have to write denominators here just so we remember what we're talking about. And then the final thing that procedure that they focused on was adding. So adding the fractions. I thought Stephen did an excellent job using explicit instruction, using the multiple representations, using concise language to set up this whole process, this procedure. There was one thing that he did that I would probably have done a little bit differently if I was the teacher of Natalia, and that involved the writing of the fractions. So in the first example, they were adding 1/4 plus 2/3, and they do all this excellent work for solving this problem, and then they come up with the answer, and it is 11/12. The one thing that I would have just encouraged Stephen to do is write the equivalent forms of the fractions when they figured them out, when they changed the fractions to like denominators. So that would have mean that 1/4 is equivalent to 3/12, and we added that to 8/12, which is equivalent to 2/3. And then here, this can emphasize, oh, I need to add the parts of the fraction. There are 11 parts. I'm always working with fractions that are with a denominator of 12. That denominator is divided into 12 equal parts. So we're going to go into our workbook activity, if I can find my clicker here. The workbook activity that you're going to embark upon is you're going to now look at an intensive intervention lesson around fractions. And I want you to try to identify as many components of explicit instruction, multiple representations, concise language, as well as fact building, problem solving, and motivational components. I want you to find as many of those components as you can, and then when you come back, we'll debrief on that lesson. Welcome back from your workbook activity. You probably did an awesome job working through this lesson and identifying the explicit instruction, the multiple representations, and the concise language. You may have also seen some fluency building activities, some problem solving, and maybe a motivational component. So let's see if we can find a few of these things together. So this whole lesson is about explicit instruction. And when I see that what they're saying, like, oh, today we're working on a word problem. First of all, that's explicit instruction, the goal, and talking about why they need to do that. They're going to solve a word problem. So there's our problem solving incorporated into this lesson. So here they are solving this problem. This is very explicit. There's lots of questions. The students are responding frequently. So we're getting at a lot of that explicit instruction. And as I look at this page 119, the students are making a representation. They're making a table to help them solve this word problem. Now, this is what their table looks like. So this is a representation of mathematics. So we are seeing mathematics in more than just the abstract, but we're working with multiple representations. And then as I go to this next page here, when I'm on page 121, where we start training, where the tutor is working with the student on deciding whether fractions are equivalent to 1/2. So when I read this part right here, I can see that they're paying attention to the language that's used within the lesson, and I see numerator and denominator. There's just so many great things to see in this lesson. So if I think about this so far, I've seen explicit instruction in play. This is all using explicit instruction. I've seen multiple representations, and we just talked about the use of concise language. We also saw problem solving, and the two things I haven't seen yet are a focus on fluency building and a motivational component. So I'm going to continue with this lesson. This is all using explicit instruction to help students place fractions on a number line, a really important concept that we've talked about in a previous module. Or wait, it wasn't a previous module, it was this module. How great is that? We are seeing the concepts of fractions in play within intensive intervention. And if I keep going, lots of good explicit instruction, lots of stuff on the number line. I'm going to keep going here because then I want to get to this part here. So we had an audio problem with last time I talked about this page, so we are re-recording it. So that's the reason I have a different outfit and it's a different time. But let's go ahead and talk about this page. So in this lesson, we've already seen good examples of explicit instruction and multiple representations and clear and concise language. And that brings us to our fourth component that should be embedded within intensive intervention, and that's fluency building. Now, often when I say fluency building, people think about math facts. So how well do you add 6 plus 5? How well do you multiply 7 times 9? But fluency building isn't always just about math facts. In fact, students have to have fluency with counting. That comes before understanding math facts. And then students should have fluency with things related to fractions. For example, listing multiples. That's going to help with common denominators. Students should also develop fluency with adding and subtracting positive and negative integers. Students should have fluency with solving 1- and 2-step equations. And there is a fluency building component. I hope you found it. It is right here. And this is our fraction sprint, and it's time for 1 minute. So this is a brief fluency practice where students have to figure out if fractions are equivalent to 1/2 or not equivalent to 1/2. And that is the fluency building activity. And that's going to be really important for students to be able to quickly identify whether a fraction is equivalent to 1/2 or not. That's going to help with comparing of fractions. That's going to help with ordering of fractions. And then that's also going to help with the operations and thinking about the estimates that will come when you add, subtract, multiply, or divide fractions, especially if you have a good understanding about what 1/2 means. This lesson also didn't really focus on problem-solving instruction on this lesson, but it does within this intervention program. They do focus on problem-solving at other times. But then the last part that we do see alive and well in this lesson is a motivation component. Here you can see it's called scoreboard. Student received dollars, and there's like half dollars and whole dollars, and then they can save up those dollars to buy little prizes. So you can see here they can go to the fraction store. So that's how the motivation component is embedded within this lesson. So we're finishing up part 3 here. We were really focusing on what does it look like when we're thinking about teaching concepts and procedures about rational numbers. So just as we talked about with whole numbers, we're going to use the same checklist here. So I want your instruction to be explicit. I need it to use multiple representations, and you need to use precise and concise language. Then as much as you can include those fluency activities. Remember, they might not always be about facts, but they can be other things that students need to establish fluency on in mathematics. I want you to focus on problem solving. Problem solving should be embedded within every lesson around intensive intervention, and you should utilize a motivation component. So let's look at our discussion board. Here I want you to make a video of yourself teaching something about fractions, decimals, or percentages. So kind of leaving this one wide open. You might focus on concepts or procedures. I want you to share your experience of making this video with your classmates so that they can see what it's like to teach something related to rational numbers. And it's also going to increase your understanding of this topic. Have fun.